All right, so I'm starting this broadcast since none of my group members have showed up yet. So I'm just going to go through the problems here. I didn't really have any questions when it came to the homework. It's pretty straightforward. Just looking at ANOVA and how that works. So I've gone through the problems, and I'm currently at question 6. We assume the variance in each group is the same if the following happens. And I think the correct answer is the largest variance is less than 4 times this. The largest variance is less than 4 times the smallest variance. Question 7. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? Okay. So it'll be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and then 3, 4. Yeah, so I think there would be 7. Let me just double check that. Oh, sorry, there would be 6. Yep. Data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from target that was hung 115 centimeters up from the ground. Column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. What is the minimum or smallest variance for the 6 groups? All right, so let's go and copy and paste all that. Okay, soccer shoes. Okay, so I'm going to go through, highlight A. Okay. Highlight B. Going back to get C. Okay. Smallest variance. And then to get the variance, you take the square of the standard deviation. So the smallest standard deviation is 5.216. Okay. So 5.216 squared, 27.207. What is the maximum variance? Okay, so that would be 7.291 squared. Okay, and that is 53.159. Test for equal variances is satisfied for these data. So it's not more than 4 times the amount of the smallest variance. So I'm going to say true. Construct a QQ plot for each of these samples. Each of the samples are approximately normal based on what you see in the QQ plots. Okay, well, I'm going to get the other spreadsheet open so I can do that. Go to the QQ plot. And let me just go back through here and double check. Oh. Okay, so the first one is definitely not normal. Same with the second one, so I'm assuming they're all not normal. Yeah. I'll go through and check all of them. Yep. Not looking good. Okay. The last one. Alright, so none of them are normal. Perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data? Okay. Oops. So the p-value right now is let's see, it says 0.081. And that looks correct. So when we remove the sixth one, let's see what happens. Well, go through highlight, clear contents. Perfect. 0.309. Okay, 0.309 is what I got. The test statistic for an ANOVA hypothesis test is an F statistic is the p-value of the area to the right or left of the F statistic. To the right, according to the reading. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry and meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file. Hot dog nutrition uses data to answer the remaining questions. Let's examine the calories first. Construct QQ plots of the calories for each of the types, and then compare the variances to determine if the assumptions to use ANOVA have been met. Okay. So, beef. Calories first. Okay. I have the beef. And it's not normal. Okay. Let's go for the meat. Well, since the beef isn't normal, then all the rest aren't going to be either. Okay. Okay, let's check if the variances are equal. So, okay. Beef again. Okay. Poultry. Okay. So all the standard deviations are relatively close, so we can assume that the variances are equal, but it's not safe to assume each group comes from a normally distributed population. So the assumptions have not been met. Okay, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should... just a minute. All right. You should find the degrees of freedom at 2. 51. The P is what conclusion can you draw? Yep, 2 and 51. P-value is 0. Yep. Have the same mean number of calories. So the F is 16.074. We have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories, is what I would think. Now let's examine the sodium levels, construct QQ plots. For you, we should see the QQ plot suggests a pop-up problem with the normality assumption. The smallest variance is the largest. Is have the assumptions been met to use ANOVA? I think you have to have QQ plot be normal for all of them. The assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal. I'm going with that one. You decide to use ANOVA if the mean sodium levels are the same for all 3 groups. What is the p-value? Okay, let's go and copy all that information. For the sodium, go to beef. Paste. Sodium for meat. Copy and paste. And we can go to poultry. Copy and paste. Perfect. So p-value, it shows 0.179. Go with that. 0.179 user level significance. Okay, so since it's greater, since it is greater than the level of significance, we can say that we are going to fail to reject the null hypothesis. Okay. And okay. And if I remember right, if we can't reject it, we do not have sufficient evidence. That's what I think. Okay, submitting quiz. Let's see what I got. Submit. Yes. 81.65%. Oh, I missed some. All right. Okay, so I missed number 15, as well as number 14, as well as 11. Okay. Question 4. Oh. Okay. Okay. Let's go to question 11. Okay. Okay. Oh, 14 was number 3. Okay. And then, okay, let me go back through and retake it really quick. Okay, 3, 4, 6, 7, 8, 9, 10, 12, 15, 16, 17, and 18. Number 2. Perfect. Go back and retake it. Start class. Okay. Third one. 6 is 2, second one. 7 is 6. 8 is 7. 7. 9. 10 is true. 11 is true. 12 is 43. 9. 13 is right. 14 is the third one. 15 is the fourth one. 16 is the third one. 17 is point. 9. 18 is the second. All right, let's see what I got the second time around. %. Okay, so I still missed one. Question 14. Okay. Whoops. Close enough. All right, well, that concludes my Hangout. I guess I could have shared the screen. That might have been easier, but that's about it. Thanks for watching. Bye.